Welcome to Unit 3, Two Variable Statistics, Lesson 10, Fossils and Flags. Before we get started, if you could take a moment and hit that subscribe button so that you're notified as I make new videos, and if you could give this video a like, that way other people are more likely to find this help and get better prepared for their algebra courses. The learning goal for this lesson is to collect some data and analyze it. In our practice problems, they're going to give us a situation, they're going to give us a table of values. We are going to need to be able to take that data table, put it into a graphing calculator, such as the Desmos.com graphing calculator, and then look at the scatter plot, the line of best fit, the equation that goes with it, the correlation coefficient, and answer some questions about what type of answers we can come up with and what types of things we cannot come up with based on what we see. We have one learning target, and that is to collect data, create a linear model to fit the data, determine if the linear model is a good fit, and use the information from my linear model to answer questions. As I said, the practice problem is going to give us a situation and a table of data. We are going to recreate that table of data in the Desmos.com calculator. We're going to take a look at all the information we get from that, and we are going to answer the questions as to whether or not the linear model is a good fit and what type of conclusions we can or cannot draw from all of this information. On our practice problem for Unit 3, Lesson 10, it says technology required. Data in the table shows the relationship between the average number of social network notifications, being represented in the left column by X, that a student receives during one class, and average test scores, being represented by Y in the right-hand column. If we scroll to the bottom, we see that we have two questions here. Number one, what conclusions, if any, can you draw from the information provided? Justify your thinking with mathematics learned from this unit. And number two, what conclusions can you not draw from the information provided? Justify your thinking with mathematics learned from this unit. So the first thing we needed to do was take this table of data and recreate it on the Desmos calculator. And to save time, I've already done that. Remember that you simply go to desmos.com/calculator, and when it comes up, hit this plus sign in the upper left that says Add Item. We see the choice here for Table, and when you click that, it will give you an X1, Y1 table. I took all the values of X from the left column, and I input them into the table, and I took all the values for Y in the right-hand column, and I placed those in the table. And here on the right, you can see the scatter plot created by all of these green dots. Now, the next thing we want to do is up here at the top, just next to the table, we see this add regression, and it looks like some scatter plot points with a line of best fit going through the middle of it. When you hit that, it's going to input your linear regression line or your line of best fit. And that's what we see here. Now, down at the bottom, it's going to give us some different information. It's going to give me the equation for the line itself. So now I know the slope, I know the y-intercept, and then down here at the bottom, what we are really concerned about in this lesson is the correlation coefficient. And we see that that is negative 0.68. So if we go back to our practice problem for number 1, our correlation coefficient of negative 0.68 suggests a negative, moderate correlation between X, which is an increase of social network notifications, and Y, a decreasing average test score. So suggests a negative moderate correlation of or between increasing social media notifications and decreasing test scores. So that's what we can say about this situation. Number 2 asks us, what conclusions can you not draw from the information provided? Justify your thinking with mathematics learned from this lesson. So the key here is that while in number 1, we can conclude that there is a negative moderate correlation between increasing social media notifications and decreasing test scores, in number 2, we can't declare increasing social media notifications are causing test scores to decrease. It's the causation that you cannot declare from this information. Now, if you ran some type of scientific study and you were able to recreate the results, then you could start trying to move toward saying that one is causing the other. But at this point, with just these statistics, the only thing you can really declare is that there is a moderate negative correlation. You cannot declare causation. So you can say, hey, it looks like these two things are related, and that when we see more social media notifications, we see these decreasing test scores, you cannot then cross that line and declare that the increased social media notifications are causing the test scores to decrease. If you have any questions about the difference between correlation and causation, please ask for help. If you're in class, go ahead and use class time to ask for that clarification. If you're watching this video online, please drop a comment and I'll get back to you with further clarification on that. Again, if you enjoy these videos or you find these videos helpful, please hit the subscribe button, give this video a thumbs up, and that way other people might be led to these videos and get the help that you're receiving.